Hey everyone, welcome to another episode of Get Certified Together series. Now, in this week's episode, remember I told you so many times that this whole syllabus looks pretty messed up because they are covering threat detection and response as part of what domain 1, while identity and access management, which I feel it should be coming in the starter, is coming all the way in the domain 4. So what I did as part of preparing this episode, and of course episode from now on, is going to AWS security fundamentals first. Now, it's pretty interesting because when I was reading the book, which I mentioned you in a couple of episodes back, the book which I'm referring, I didn't refer it all. I was going through AWS material, which AWS officially provides. I was checking those material and they start with AWS security fundamentals. And I felt like this is what I was really talking about, because before we move into like threat detection and response, we should be really concerned about what AWS security fundamentals look like. What's an AWS security, as in from the basic level. If you and me who are learning for the first time, who are new to the cloud, I'm not new to the cloud, but if you are new to the cloud and you don't even know what cloud is, and if you are still going through that journey and you are still in that initial phase, like how I started, means this is how I started when I started learning about cloud. I started with EC2 instances, virtual machines, and VPCs, IP addresses, all those sort of things before I really started thinking about how I can secure this infrastructure. And that's something we should be targeting as part of this whole series as well. So this was my idea, and the book which I'm referring and the AWS material, official material which I'm referring, both of which are complementing and both of which are supporting the kind of idea which I had in mind. So like I said, we are on the right path. And what I did as part of today's episode preparation is I went to AWS security fundamentals. So I brought to you in today's episode some of the interesting concepts around that. Before we dive into main episode, I want to share one of the project which I'm doing as part of my regular job. So what idea was behind that project was I have to move some application which are running on on-prem infrastructure all the way into the cloud. Because we are moving into the cloud, I had two options. One of them using our EC2 instances and virtual machine. That's pretty normal, right? Everyone think about that. Second option is create an EC2 instance. You convert it into a Docker containerized application or infrastructure layer. Means Docker is one of the way to do it. You can use different services to make the whole infrastructure, whole virtual machine as a container supporting platform. So second option was that. And third option was using AWS managed services, which is EKS and ECS. So what I thought that if I go with EKS, it actually complements what I'm doing as part of my podcast, because what I'm doing as part of my series is I'm learning about cloud security. And one of the aspects, if you go into domain 3, it really covers like we should be using microservices, we should be having ECRs and all those sort of image builders. What the main idea is, we have to make sure that our blast radius is minimal, our attack surface is minimal, and container solution or containerized application provides just like that. So as part of that project, I was actually trying to learn more and more stuff about EKS, about how we can share AWS secrets to our containerized application, or pods as they call in Kubernetes, and how we can share those secrets across the account as well. So I was doing all those interesting aspects from the point of view of security. And the reason why I was doing that was because they are clearly mentioned in section 3 in some of the task statements around how we can share secrets and what the best way to share your secrets to your application, how you can build your microservices based application, how to reduce the attack surface and everything. So like I said, I want to learn more about that technology and I want to work on that project because I wanted to share the knowledge with you guys, because it's really nice to do that stuff. And I felt like I have achieved something because finally my containerized application is up on EKS cluster. So as part of domain 3, whenever we'll be there, I will be sharing with you guys my learning part of my project. So that will be covered as well. But I just wanted to share with you, and that actually justify why this episode is actually delayed by 1 week, because last whole weekend I was doing that and I was building that application. So I was pretty fucked up in my mind because I had to deliver that application and that project. I had to finish that off. And I was in no mindset of recording something. And I apologize to you guys because I said that I will be recording it every week. But of course, there's a valid reason this time. And whatever I learned as part of skipping that weekend, I will be sharing with you whenever we cover domain 3 as part of infrastructure security. So as part of main episode, after this break, I will be covering AWS security fundamentals. Welcome back. So let's move into AWS security fundamentals. Now, as part of securing your cloud infrastructure, AWS actually covers some of the design principles. Now, these design principles can come from the point of view of a solution architect or from the point of view of a cloud security architect. When we talk about solution architect, of course, your concentration mainly is on building up your application and building up your infrastructure. What you're more concerned about is like which region support which part of the service, what sort of design you are looking for. And if you are using like multiple services, then you don't want any sort of latency in between, right? Or having, if your application is around streaming services, then of course you have to use those kind of services from AWS, which are around content delivery and around lower latency, more synchronization between different application. If you are hosting a cloud-based banking application, your databases which are running on different hosts, they should be always in sync, and they should be having particular most efficient read write between different databases. So of course, design principle varies from the point of view of particular architect who is building that application or who is building that infrastructure. From the security perspective, ideas change because now you are more concerned about the security of your infrastructure. So you might not be that concerned about all these synchronization or read writes or latency. You might not be that much concerned about that. Of course, as a end business goal, as your organization, if they are selling some application, you don't want, because you're part of that organization, right? So even though you are coming from a security background, even though you're thinking from security's point of view, still you cannot justify that because of this security consideration. I'm more concerned about making my application more secure and less concerned about the real operational benefit or real return of investment on the whole application sale and revenue. You don't want to justify more security, and that actually takes more precedence compared to getting the real revenue, right? Because that's how we all getting paid. So design principle, of course, have to be nice balance between how to make your application more secure, but of course you don't want to get in wrong feathers with your finance team or your operational team or your infrastructure team. Means I am from infrastructure side of things, so I completely understand when I receive these kind of feedback like this, your application or your infrastructure which you are building or you have built as part of your design is not secure, and we recommend that you delete everything or you destroy everything and refactor and re-architect, making it more secure. I understand the kind of frustration which, as an IT administrator, we feel like someone is asking us to do all those sort of things without any background. And that's one of the idea why I started this whole security services journey, because now I'm getting the point of view of security guys, and of course I myself is a sysadmin from IT, so I understand my side of things as well. So AWS actually provides some key design principles. One of them is implementing a strong identity function. Now, once again, this design principle is coming up as number one when we go to AWS security fundamental course. Now you can understand, right? That's why I keep on saying that identity should be coming first as part of any certification or any journey which you are going. So identity is coming first as part of design principle, and we have to build a strong identity. Of course, we can use multi-factor authentication and all those sort of things we have already covered in CCSP, but they are fundamentals now. You should be having multi-factor authentication. You should be having single sign-on, federated identity. All those sort of things should be there as part of your design principle. Another thing is you need to have proper monitoring and tracing solution. So what is happening in the cloud, you should have trace of everything. By trace is not TCP dump. If you are in the IT, you know that TCP dump is one of the tool which you can use on Linux to capture the packets. By trace, you mean have full visibility on what's going in and out between different AWS services. Because with public cloud, what's happening is we have more than one services, more than one regions across the globe. And what is happening in one region, and within that region, maybe you have multiple VPCs, multiple accounts, and of course, different applications running in different availability zones. Everything is quite segregated, and if you don't have full visibility of what's going in and out or what's happening in your infrastructure, it's a big security risk. So traceability and monitoring is one of the key concepts around that. Of course, you need automation, because when you don't have automation, if you're doing anything manually as part of maybe log analysis, you might be able to achieve, or you might be able to find out like who did something wrong in your infrastructure, but by the time you will get that result, it's already over and done. So the key thing is, if you are going with this best practices of security, you should actually target automation as well. I've seen it means not to say anything like bad about the real security guys, because of course they know more than me as part of security and they have better idea about the security fundamentals. But felt that most of the people who are in security side of business who are new to the cloud, they are not aware of how those automation. They don't know how to use infrastructure as a code tools, Terraform and Ansible and all those sort of things. And they sometimes even get confused in between different tools. So that's a big kind of setback if you are into the security side of thing and you don't know automation and you don't know how to build and how to scale your security solution. Because as part of administrator or as part of architecting, the other point of which I mentioned, people who are working to build the application or build the infrastructure, they know more about these tools and they have better idea about this tool. I completely agree on that. But why we want to learn that tool? Because we want to scale up our design, because we want to build more applications, we want to make it available to the end users in a better speed. Means that's how all those DevOps and CI/CD methodologies they came in picture. Because what you want is you want to build the infrastructure, you want to build the application, you want to code it, and you want to release it as soon as you can. And of course, the whole pipeline and whole automation. That's what you want to achieve with this with the whole concept. Now, from the security side of things, if you're still working on the older mindset of like using basic tools, then it won't be that scalable and it won't be that automated. And of course, you will find a lot of clashes happening with your team members and your within organization like business units when you are in that situation where people who know more than you from the tooling side or from the automation side suddenly felt like they kind of suppress you, because even though you know more about the security side of things, you might not be able to justify or you might not be able to make sure that people actually work on those security concepts. Because what you end up doing is like suggesting some solution to make your infrastructure more secure, but you won't be able to guide them on the best way to do it. So automation is key, not in terms of like designing the infrastructure, but of course it's a key in terms of delivering your own solutions as well. Another thing is data in transit and data at rest. I mean, protecting data is one of the key thing which we highlighted in CCSP as well. There's a whole big domain around that. So data life cycle and how we can secure data in between different stages, what kind of technologies we have to use in terms of encryption and data anonymization, obfuscation. All those concepts are key to data security. And of course, data, even though it's AWS or it can be Azure, it can be GCP, data still plays a pivot role in determining like how secure your application is. And of course, you have to prepare for security events as well, because what you don't want that your application, you have built everything and your infrastructure is running absolutely fine and you have all those sort of fancy tools and automation in place. What you don't want is end up having a security incident and then suddenly you realize that, oops, you haven't prepared for this particular bit though. So prepare for security incidents is another key as part of these design principles. Now, one thing which I find out which is pretty good in this security fundamentals course or material, whatever you want to say. So it's free of course, means you can also go and check it out. Is they have shared this AWS shared security model or shared responsibility model. What I'm not sure, but I have covered it either in CompTIA or either in CCSP. But responsibility model is pretty basic. Means we all know that cloud is a work on shared responsibility. It's not like if I'm cloud customer, then I can just hand over all the security responsibility onto the cloud. And from same goes for AWS perspective as well. It's not like that. Because they are providing us infrastructure doesn't mean that they simply say that, okay, everything is responsibility of customer to make the whole stack secure. So of course there's a shared responsibility, and that shared responsibility actually varies in terms of what kind of service model you are buying. Now, if you recall, in CCSP Cloud Computing Fundamentals, we covered different service model. Three were there: infrastructure as a service, platform as a service, and software as a service. Now, based on the type of service which you are using, of course, that whole responsibility changes, because some parts which are in control of AWS suddenly comes in control of customer, and some parts which are in control of customer suddenly comes in control of AWS. So whole shared responsibility model varies what kind of service model you are putting onto the cloud or you are getting from AWS. They have also shared a nice diagram, which I will be showing you shortly. So what I did is I am also preparing a nice GitHub repo in which I'll be putting up some of these snippets and some of these diagrams which I'm preparing as part of my maybe fancy project which I mentioned around EKS or all those secret services and secret managers, and like the share responsibility model. So there are some nice diagrams and snippets. I'll be uploading it up on my GitHub repo, and of course I'll make it public. So those of you who want to check that out, they can check it out there, whatever snippets or whatever design diagrams I'll be putting. It won't have any content, as in it won't have any transcripts or anything. It will be only having pictures and diagrams, because I love to draw. I'm not really good in that, but I love to draw. Means whenever I get chance, or whenever I'm trying to understand a complex problem around cloud design or any design, to be honest, I try to make it. I try to use my this nice trio picture and put in different components. It really helps you out to understand the problem, and of course putting the solution to the end. All right, so this is the website which I was talking about. I mean, it's not a website; it's a GitHub repo. So in this repo, I'll be uploading all the design and everything. And this is the share responsibility model which I was talking about. So you can see, right, it's pretty clear from the picture that it's different services have different responsibility in terms of like who is managing what. In this particular picture, I think it's specifically talking about the infrastructure as a service model, because you can see the foundation services are under AWS control, but of course anything on top of that is under customer's control. Now the bit which I'm talking about, like this operating system, networking, firewall configuration, if you are using infrastructure as a service, there comes under your jurisdiction as a customer. You have to do, and you have to make sure that everything is patched. You have to make sure that you are only opening the ports which are required. You are not completely you are not deploying anything which is not required. All those sort of fancy thing comes under this infrastructure as a service responsibility model. Things change when you are using platform as a service, because then operating system, networking, firewall configuration, everything comes under the jurisdiction of AWS. And of course, you as a customer will get a nice platform on which you can test and you can deploy your services and everything. So that's how it changes. And of course, if you are using software as a service, you will end up getting a nice front end, and you don't have to do anything. Means what you have to do is you have to just put your data and you have to start using it. Let me give you some of the examples of the each service in terms of AWS. So EC2 instance, for example, is a part of infrastructure as a service. Means it's a no-brainer. It's just a blank virtual machine. You have to decide as a customer what kind of operating system you want, what kind of security groups you want, whether you want encryption of your block storage volume, or um, how you want to access it. If you want to make it a domain joined machine, whether you want to use single sign-on or you want to use a key pair, everything is under your control and you can do it. I think for platform as a service, AWS Beanstalk is one of the application which I recall is part of platform as a service, because what you get as part of AWS Beanstalk is a nice set of application which you can choose, and once you like click deploy that application, you will get a whole stack. What you will get is like whatever application you choose, what kind of I don't know, Java platform or Python libraries, all those sort of things will be there as part of that Beanstalk deployment. You will get access to that. You won't care what kind of networking it's using in backend, what kind of ports and service groups it's using, whether the volume is encrypted or not. What you care about is all those libraries and processes, they are available as part of that Beanstalk application. For software as a service, I think S3 should fit perfectly, because S3 is a front end. You can even create a static website on that. You don't know where the data is stored, what kind of encryption is used, what kind of SAN architecture is used in the backend, whether it's SAN or NAS. You don't really care about anything. What you really care about is a nice GUI on which, or a console, or even your command line on which you can just dump your files. You don't care about anything. You can of course control what kind of access you want, or what kind of permission you want to give on the files which are uploaded there, and how you want to access them, and whether you want to encrypt it from your own key, or you AWS can do it for your as your on your behalf as well. So I think S3 fits perfectly well in terms of whether it's a software service. So those are from the AWS perspective. Now, of course, you can say like, oh wait, OneDrive, Gmail, yeah, they are part of software as a service as well, but of course they are not provided by AWS. I think this is the shared responsibility model which I wanted to cover with you guys, and It's pretty basic, it's pretty easy, but it's nice to understand from the AWS perspective, like what AWS think about that. Now, another thing which I will be sharing the link in the show notes about from where I got this diagram. I don't know whether it's open in one of the tabs, so I'm not going through that. But what I got is this nice snippet of cloud adoption framework from security perspective. There's a cloud adoption framework from architect or infrastructure perspective as well that completely cover the other point of view which I mentioned, those from the IT and sysadmin's point of view. But this one actually covers only from the security perspective. So you can see all those terms around security governance, security assurance, identity and access management, threat detection, vulnerability management, infrastructure protection, data protection, application security, incident response. They are part of cloud adoption framework. Now, what AWS mean by cloud adoption framework is, if you are new to the cloud, if you are not having any infrastructure onto the cloud, you have to consider at least these, because this will help you build a secure environment around cloud infrastructure or cloud services. So, security governance, of course, you have to develop and communicate security roles and responsibilities, policies and processes and procedures everywhere. So in your organization, if you are, for example, doing it for the first time and you are moving your some of the application from your on-prem to the cloud, if you don't have properly defined roles and responsibilities, because cloud is big thing, right? Once you start moving infrastructure for one of organization unit, maybe you have more organization units or business departments, they want to move to the cloud as well. You have to segregate responsibilities around ownership of different accounts. It helps in the costing as well, because in a way, if you have different accounts, then not only you have segregated rules, but also you have segregated budgets as well, so you can clearly define like which department is owning which part of infra and how much it's costing to the whole organization. So that everything is covered under security governance. Security assurance is nothing but monitoring and making sure your applications, your infrastructure is up and always managed according to the security policies. It's less from the perspective of CPU, memory utilization, and all those sort of things. It's more from the assurance of security perspective. There is no incidents and make sure that everything is secure. Identity and access management is, again, means that you don't have to say anything around that. It's simply you have to manage all the identities into the cloud. If you are building it something in, means it happened to me as well. I've seen it in a lot of organization where people, they move to the cloud infrastructure only to realize later that, oh, you cannot use AWS native IAM users and roles because they are not scalable. Plus, of course, you don't want to have these like those static access keys and everything. So what you want is, you want a single sign-on. You have to use other services from AWS Identity Center, maybe join it with your existing on-prem AD or something. So IAM is a big thing, and of course, I have worked a lot of projects around IAM. So whenever this topic will come, I think in domain 4, it will be interesting because I have a lot of knowledge with you guys to share, and maybe it might get overwhelming at a time. But yeah, IAM is really critical. Threat detection, nothing but you have to understand and identify potential threats, any like security misconfiguration, make sure your ports are not open, make sure you have unnecessary applications and unnecessary processes removed or at least deleted, or at least in stopped or disabled state in your operating system. Vulnerability management is around identifying those latest CVEs. They comes in daily. Oh, by the CVEs, I recall that. Have you seen this Oracle hack which happened? Like, I have written the number somewhere, but I think millions of user identities are leaked because Oracle Cloud actually, I think there's a vulnerability in there, one of the database, which led to that leakage. And one of the thing which was interesting was that Oracle Cloud Management, people who own that infrastructure, they initially denied and they said that there is no such thing as this hack or leak. Everything is pretty normal, only to come up in a week or so to say like, yeah, this is something which happened, and we realize that it's leaked everywhere. I think I was planning to cover that in today's episode, but my notes, I cannot see it anywhere. So maybe in next week episode I will share with you those stats and number, and it's pretty interesting in that Oracle Cloud thing. Anyways, so infrastructure protection, this is covered under domain 3. how we can validate the system and services within your workload are protected, data protection, maintaining visibility and control over your data and how it is accessed and used in your organization. Application security is nothing but your application is always secure and you detect any sort of misconfiguration, any sort of unidentified access into your application, how you are storing the data which is uploaded on the application, where you are hosting it, all those sort of things is covered as part of application security. Not to forget the new updates in the application, new SBOM and everything, like what kind of different softwares and different repository you are using as part of building your application. So that everything is covered under part of application security and incident response. So if something goes wrong, what's your plan? How you can how you going to respond to it and how you're going to resolve it. So this whole is covered as part of cloud adoption framework. With this shared responsibility model and with this adoption framework, now I think we are pretty much confident on what is the main idea behind AWS security fundamentals and how we have to approach this security concept when we are understanding from the AWS perspective. As part of next week episode, what I'll be doing is I'm covering through these security fundamentals more. So some of the concepts are around data center security, which are not relevant that much to us because, to be honest, we are anyhow not allowed to know where AWS data center is. But they have covered it, so we can go into that as well. I think it's not relevant, but no harm in going through it. Of course, there are some mention about controls, detective controls, infrastructure protection, data protection, incident response. They have covered them briefly. I will share the link in the show notes as well. You can go into them, you can read them yourself. Language is pretty easy. I feel like this is something you can do yourself as well. But of course, if you don't feel like doing it, then I'm here and I will be going through it anyhow. So once this security fundamentals is over, I think by the end of that, we will be pretty much confident on how we want to approach and what sort of domain we cover first. Because I still feel like domain 4 should be coming first because domain 4 is IAM, and IAM should be coming first before we move into infrastructure security and I don't know, data application security and threat detection and this one. So I'm pretty confident and I'm pretty honest that in a way that after security fundamentals, we will be going through IAM. But again, keep tuned to this podcast because things might change as I go into more information around that. But as of now, yeah, that's the whole plan in front of us. So that's all for today's episode. And I again apologize for missing 1 week because I was pretty much deep inside the work which I was doing for my this EKS cluster and Kubernetes. It's really interesting, and once you are trying to achieve or trying to solve a problem, you feel like let's solve it first before you do something else. So that's the mode I was in, and finally I'm in mode of like sharing the knowledge with you guys. So that's all for today's episode, and if you feel like this is something really interesting for you and you want to share with other friends and with someone who might find the whole content helpful, then of course like and subscribe. I don't feel like saying it, but if you really want it, then please like and subscribe, and let's catch up in the next week episode and let's go into this AWS security fundamentals more. Goodbye and good luck.